Good morning, my dear students. In this particular video presentation, again, we will discuss the remaining problems from exercise 7.2 on integration from NCERT textbook. We'll continue with the 16th problem. 16th problem goes like this. Integral e power 2x plus 3 dx. We need to have a clear observation that derivative of 2x plus 3 is 2. Therefore, I will just multiply and divide by 2 in the second step. Then this 2 dx can be written as d of 2x plus 3. d of 2x plus 3 is 2 dx plus 0. Whenever I have d of, I should multiply dx. Just remember carefully. When I write d by dx, I will write simply the answer as 2. That is called derivative of 2x plus 3. The differential coefficient of 2x plus 3 is written as d of 2x plus 3. Now close this off with your hands and you can verify this is my substitution. Therefore, it's of the form half integral e power t dt, where what is my t? T is 2x plus 3. Therefore, I'll end up with e power t by 2 plus c. That is e power 2x plus 3 by 2 plus c is the final answer. I'll just repeat. Integral e power 2x plus 3 dx. Derivative of 2x plus 3 is nothing but 2. Now, for multiply and divide by 2 in the second step. Now, for this 2 dx can be written as d of 2x plus 3. d of 2x plus 3 is 2 dx plus 0. Derivative of 3 is 0. Replace this by t. So the form integral e power t dt, but t is 2x plus 3. Now for integral e power t dt is e power t. Therefore e power 2x plus 3 plus 2 will be the final answer. Then for the 17th problem, x dx by e power x square. Now derivative of x square is 2x. Therefore multiply and divide by 2 in the next step. 2x dx by e power x square. Therefore, this will be in fact is equal to e power minus x square d of x square I will have. Therefore, here again I mean to say e power minus t dt, e power minus t dt, where my t is x square. My t is x square. I'll write it as e power minus t dt, where my t is x square. Therefore, this will be minus e power minus t by 2 plus c, or you can divide by minus 1. Either way you can write. Therefore, minus e power minus x square by 2 plus c. You can even multiply minus off and multiply and divide by minus 2. And you can even write like this as d of minus x square. Here it will become e power t dt there. Automatically it will end up with the minus sign will be there in the second step itself. Automatically which will be carried over till the end of the steps. I repeat. Multiply and divide by 2. Half integral e power minus x square d of x square. d of x square is 2x dx. Whenever write d of I should multiply dx. Just recall that rule. Half integral e power minus t dt, where t is x square, minus e power minus t by 2, or e power minus t by minus 1 into 2 is the denominator already there. Now for minus e power minus x square plus c will be the final answer. That will be the final answer. It is not at all difficult. Instead of writing t is equal to etc, 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 I am doing it directly. It is not at all a difficult process. You need to just recall one simple rule. D of a quantity, a function which we write. Whenever we write, we are supposed to multiply dx along with that. Remember only that particular rule. That will make it easier. That will make our job easier. Then for the 18th problem, integral e power tan inverse x dx by 1 plus x square. It is e power tan inverse x dx by 1 plus x square. Let me write. Here I mean to say integral e power tan inverse x d of tan inverse x. d of tan inverse x is nothing but dx by 1 plus x square. Therefore, replace this by t, e power t dt, where my t is tan inverse x. This is nothing but e power t plus c, which is e power tan inverse x plus c. Let me just recall integral e power tan inverse x dx by 1 plus x square. Let me group dx by 1 plus x square. Dx by 1 plus x square can be written as d of tan inverse x. Whenever I have d of, recall I should multiply dx. This is called differential coefficient. Now for replace this by t, e power t dt, where t is tan inverse x. Integral e power t dt is e power t. Therefore e power tan inverse x plus c will be the final answer. 19th problem is little bit different. Just see here, e power 2x minus 1 by e power 2x plus 1 dx. What I will do is, I will just take away e power x as common. E power x plus minus 1 by e power x dx. Sorry, there is a minus sign. I wrote it as plus in the numerator. E power x minus e power minus x in the numerator. E power x into e power x plus 1 by e power x. This e power x gets cancelled. This is e power x minus e power minus x dx by e power x plus e power minus x. If you observe carefully, derivative e power x is e power x. Derivative e power minus x is minus e power minus x, which is there in the numerator. Therefore, this can be written as d of e power x plus e power minus x by e power x plus e power minus x. You can just verify d of e power x is e power x, d of e power minus x minus e power minus x into dx I will write. Now replace this by t. This is the form dt by t, which is dt by t, where my t is e power x plus e power minus x, which is log mod t plus c, which is log mod e power x plus e power minus x plus c. Let me just repeat. The second step, take e power x as common from both numerator and denominator. This will become e power x. I will write 1 by e power x, then only this will get cancelled. This 1 by e power x can be written as e power minus x. Derivative e power x is e power x, e power minus x minus e power minus x is there in the numerator. Numerator can be written as d of the quantity in the denominator, the function in the denominator. It's the form dt by t, but t is the denominator. Integral dt by t is log mod t. Therefore, I end up with automatically log e power x plus e power minus x plus c will be the final answer. That will be the final answer. Then for the 20th problem, e power 2x minus e power minus 2x dx divided by e power 2x plus e power minus 2x. If you observe carefully, derivative of e power 2x is 2 e power 2x. Derivative e power minus 2x is minus 2 e power minus 2x. Therefore, multiply and divide by 2 in the second step. 2 e power 2x minus 2 e power minus 2x dx divided by e power 2x plus e power minus 2x, which will become half d of e power 2x plus e power minus 2x divided by e power 2x plus e power minus 2x. This will become half integral dt by t, where my t is the denominator, e power 2x plus e power minus 2x. Therefore, this will become half e power t plus c, which is half e power 2x plus e power minus 2x plus c will be the final answer. Let me just recall once again, derivative e power 2x is 2 e power 2x, derivative e power minus 2x minus 2 e power minus 2x. Therefore, multiply and divide by 2 in the second step. This can be replaced by d of e power 2x plus e power minus 2x. Close this off. This is my t. Half integral dt by t, where t is my denominator. Sorry, I made a mistake. Here. Sorry, I'm extremely sorry. Without noticing, I wrote it as e power t, which is half log mod t. Sorry, half log mod t. See the correction. Sorry, half log mod e power 2x plus e power minus 2x plus c. Without noticing, I took it as e power t. Sorry. Similar to this, I thought it is not e power t, dt by t, which is log mod t, of half log mod e power 2x plus e power minus 2x plus c. Let me repeat after this step. Replace this by t, so form dt by t. Dt by t is log mod t. Sorry, I took it as e power t. Extremely sorry. Now half log mod t plus c, half log mod e power 2x, e power minus 2x plus c. See the correction here. Anyway, I rubbed it off. The previous step I rubbed it off. It is wrong anyway. It is wrong. Okay, therefore I have covered up to the 28th problem. I hope everything will be very useful to you. You can share the videos with your friends and relatives and people known to you. You can advise them by clicking the subscribe button and bell icon and watch. Subscription has no charges. I will check for the calculations. See, this correction I have already done. Anyway, I'll check for the remaining 4 sums also. Thank you for patient watching. Rest we'll discuss in the next video. Thank you.